Welcome in another video. Today we are going to discuss the polyatomic ions. A polyatomic ion is also known as a molecular ion, is a covalent bonded set of two or more atoms or of a metal complex that can be considered to behave as a single unit and that has a net charge that is not zero. A polyatomic ion could be negative, just like this formula here, or could be positive, just like here. Let's practice and solve some examples, some practice problems here. So the first example is the hydroxide ion. It is an OH negative. Let me write it. It is OH negative 1. And actually, this negative charge should be located on an oxygen, but we write it like this way for simplicity reasons, okay? Sulfate anion, SO4, 2 negative. Sulfite is one oxygen less, right? So SO3, 2 negative. As we can see here, the sulfate ends with the suffix ate, and the sulfite ends with the suffix ite because it has less oxygens. When you have more oxygens, you add the suffix ate. When you have less oxygens, you have the suffix ite. When you have for example, a nonmetal such as sulfur connected with oxygen, you have two options. You have to add either ate or ite, and it depends on the number of oxygens in this polyatomic ion. Okay, we have then nitrate. Nitrate is NO3, 1 negative, and the nitrite, which is one oxygen less, as you can see here, you decrease it by one oxygen here, so it's transformed into nitrite. It was nitrate, and then it's transformed into nitrite. You can see the difference. How about phosphate and phosphates? Phosphates is PO4, 3 negative, and phosphates is just like PO3, 3 negative. How about the hypochlorite? Let's see here. Let's write the chloride and the chloride first. So chloride should be like this: ClO2, 1 negative, and the chlorate, this is ite, and the ate formula, you have to, the chlorate has one oxygen more, so it should be like this: chlorate. How about the pair prefix? Pair chlorate, that means you have to add more oxygens, okay? So ClO4, 1 negative. How about the hypo? You have to remove another oxygen from the chloride, hypochlorite. So you remove one oxygen. So at the end, it should be ClO, 1 negative. I hope you can get the difference now, okay? How about hypobromite? Let's solve bromite and bromates. Then we move to hypobromite and pair bromate. Okay, bromite is ClO2, 1 negative, bromate, sorry, BRO, 1 negative, sorry. So it should be BRO, 1 negative, and bromate is BRO2 negative, and bromate is BRO3, 1 negative. How about the hypobromite? It should be one oxygen less, BRO1 negative, and pair bromate, it is like BRO4, 1 negative. How about the chromates? Chromates is just like CrO4, 2 negative, and the dichromates, Cr2O7, 2 negative. Then we have permanganate. Permanganate is MnO4, 1 negative. Thiosulfates is S2O3, 2 negative. Then we move into the positively charged polyatomic ions. We have here the ammonium, should be NH4, 1 positive. Hydronium, H3O1 positive. Phosphonium, PH4, 1 positive. So maybe we can take some practice problems. That's right, some practice problems here. How about this compound, K2SO4? What is the name of this compound? So this is potassium, this is the cation, potassium, and then this is the sulfate, potassium sulfate. How about something like this, Ca3PO4 by 2, as you can see here, because the PO4 has the valency of 3 negative and calcium has the valency of 2 positive. So you exchange the valencies and you get calcium phosphate. How about something like MgNO3 by 2, since magnesium is 2 positive and the nitrate is 1 negative, so you have to exchange the valencies, and you have here magnesium, and you have here magnesium nitrate, and so on and so forth. I hope you got it, and see you in the next video. Bye.